Dear students, welcome to the video, the derivative of exponential functions. In this video, we are going to find how to find derivative of exponential functions of forms e to the power of u, where u is an expression in terms of x. So, given that u is e to the power of u, where u is an expression in terms of x. Now, when you want to differentiate such a function, you first differentiate power. Do not confuse it with polynomials x to the power of n that you bring power down and you subtract 1 from the power. It has completely different rule. So first you differentiate power, it will be u prime. Then you write the same thing e to the power of u. Just the differential of power will come as the coefficient behind e to the power of u. Now let's see some examples. Now first example, differentiate with respect to x. First one, e to the power of 2x. Y is e to the power of 2x. Now as you see here, actually it is u. The rule that we just learned says that first differentiate power, which is 2, differentiation of 2x is 2, then write the same thing, e to the power of 2x. For the first part B, x e to the power of negative 5x. So here you should use product rule because you have a combination of product of two functions. So y is equal to e x to the power of negative 5x. Now as you have product rule should be implemented. Differentiation of x. So I write product rule here. If you remember, u prime v plus v prime u. Now differentiation of x is 1, so 1 times e to the power of minus 5x plus differentiation of this. Differentiation of this expression is actually the rule we just learned, differentiation of power, negative 5 e to the power of negative 5x. Now times x. Then it will become e to the power of negative 5x minus 5x e to the power of negative 5x. Then for part C, you have quotient rule. It's a fraction. So y is equal to e to the power of 3x over x squared. Now, differentiation of numerator. I write quotient rule here. U prime v minus v prime u over v squared for u over v. So differentiation of e to the power of 3x. It will be 3 to the power of 3x times x squared minus differentiation of denominator, which is 2x times numerator, e to the power of 3x over x squared to the power of 2 will be x4. And that's it. Example 2, the equation of a curve is y is equal to e to the power of 2x minus 9 e to the power of x plus 7x. Find the exact value of x coordinate of each of the stationary points and determine the nature of each stationary point. Now, we know that in order to find coordinates of x coordinates of stationary points, we need to have the first differentiation. So it will be differentiation of e to the power of 2x is 2 e to the power of 2x. Minus differentiation of e to the power of x is again 1 e to the power of 2x, so you have a 9 e to the power of x, then plus 7, which is differentiation of 7x. Now, we already learned in AS level that in order to determine the nature of the stationary point, you need to have second derivative. Now I find the second derivative here. Differentiation of e to the power of 2x is 2 e to the power of 2x, you have a 2 here, 4 e to the power of 2x, minus 9 e to the power of x, then differentiation of 7 is 0. Now next part is to find the roots of the first differentiation. So 2 e to the power of 2x minus 9 e to the power of x plus 7 is equal to 0. Now I rewrite it in this form. S squared minus 9 e to the power of x plus 7, 0. Now let e to the power of x be, for example, you can write y, it would be 2y squared Let me, in order to not to confuse with y coordinate, I change it to for example t. 2t squared minus 9t plus 7 is equal to 0. Then if you factorize it, it would be 2t minus 7 times t minus 1 is equal to 0. So t1 is 7 over 2 and 1s will be positive 1. Now we have t, so t was e to the power of x is equal to 7 over 2. Once e to the power of x is equal to 1. Now here in this case, if you take ln from both sides, ln of 1 is 0, so x will be 0. And for the second one, x will be ln of 7 over 2. These are the x coordinates of the stationary point. Now we should see the nature of each stationary point. So these points must be replaced in the second differentiation here. Second differentiation. Now if x is equal to 0, second differentiation will be 4e to the power of 0 minus 9e to the power of 0. So it will be 4 minus 9, negative 5. It is negative, which gives you negative 5, which is less than 0. So when the second derivative is less than 0, it means that the curve bends downwards at that point. So it means that x is equal to 0 is the x coordinate of a maximum point. For the second one, ln of 7 over 2, if x is ln of 7 over 2, now second derivative will be 4 e to the power of 2 ln of 7 over 2 minus 9 to the power of ln of 7 over 2. So second derivative will be equal to 2 will go inside as the power. We know this rule, a to the power of log of b to the base a is b. So as ln has the base e and 2 is the power, so it will be 49 over 4. So it will be 4 times 49 over 4 minus this number will be 7 over 2. So times 9, 63 over 2, 4 cancel out each other. Then it will be 49 minus 31.5, giving you an answer of 17.5, which is more than 0. It is more than 0. It means that the curve bends upwards. So x is equal to ln of 7 over 2 is a point of minimum. Thanks for watching this video.